Okay, so my name is Matt Payne and I teach history at Emory University. And one of the things we always have to deal with undergraduates in history is science and the scientific revolution. It's always a touchy thing because the way people think science works is not the way that science actually works, okay? And I was thinking about what I tell my students and what I should tell the world because I know these guys. These guys have got a new company with a new technology, and it looks to be pretty neat, okay? But they're doubting themselves. They're sitting there going, well, look, we don't have degrees, we don't have nice white lab coats, we don't have big labs, we just have an idea. And, in testing the idea, it seems to work, but, maybe we're wrong because, we're not PhDs and we're not in big corporate R&D programs, okay? How would we come up with this new innovation? The answer to their question, of course, if you read Thomas Kuhn's work and other people's work on how scientific innovation actually works, not how we think it works, okay, is that they're precisely the people who should be doing this. Because our popular conception of science is really, it's very incremental. There are these guys with walkers, and they're walking the science a little bit further. They're trying to push it a little bit further, get a little bit more data. They come up with a little bit of a tweaking of their ideas, and so it goes. And in fact, a lot of scientific establishments really work that way. In a sense, scientific communities work within their own interpretive frameworks. And it's always a little rough to get outside of those frameworks. It's being a rebel. And even if you're a rebel with a cause in science, people don't like rebels. They rock the boat. They maybe cause trouble, okay? So for a lot of reasons, many of the new theories and ways of looking at the world, completely changing the framework of science, comes from outside, comes from the rebels with a cause, okay? And what Kuhn would call this is a paradigm shift. He would just point out that the way things work is not that we come up with neat little hypotheses and then find empirical data to support them. Oh no, that is way too simple, okay? What really happens is that over the course of time, while we're working within our paradigm works in a lovely way. It explains everything. We don't need to go outside the box because we built a very nice box. And that box, for instance, if you're talking about physics, right, it's Newton, De Principia. What could be better than De Principia? It explains everything. It explains things even so well that he can use it in Latin and everybody will go and read it anyway, okay? And particularly he explained the physics of things that people couldn't explain before, like gravity. And it worked great. I mean, these calculations and formulas were simple, they were precise, they explained the world to you. You could run them with a slide rule. In fact, they did run them with a slide rule for centuries. And for centuries, so it worked. However, there was always a little bit of squishiness with Newton's physics, sort of at the edges. It didn't seem to work so well with light. It didn't seem to work so well with how we thought things worked at very fast speeds or very big scales. It didn't seem to work very well, or so we thought, at the lower levels. But that's okay. Those are special cases. We won't worry too much about them. Let's keep on pushing science along with our walker, right? Well, there's a few guys who are saying, like, what are we doing to walker? Why don't we try a pole vault and just vault over all this stuff, right? And come up with a new way of thinking. These sort of guys usually didn't do well professionally. I mean, they were kind of shunted to the side. Great example of this is this very smart fella, bit eccentric, never used a comb in his life on his hair, okay? Who ended up, for his weird ideas, kind of drummed out of academia altogether as a young man. He was off in the patent office, of all places, being a clerk. Now, if you can't think of a worse gulag for an aspiring, theoretical physicist than the patent office, I'd like to hear it, because I don't know one that would be worse. Now, in his paper-pushing job, however, he did have lots of time to do thought experiments. And the more he thought about things, the more he thought, gravity doesn't make sense in terms of two objects interacting with each other. It makes much more sense in terms of hey, I got it. There's this time-space continuum. And you know, like, dude, gravity is mass actually pushing down and warping the fabric of time and space. Okay? Now, he presents this argument, and people are really impressed because, look, the math is beautiful, and it's out there. But not very many people are willing to take it up, and lots of people really criticize it and said, oh, this is wacky. But some people began to look where this fellow, and his name, of course, was Einstein, told them to look. And in looking, they found things such as, you know, light really does bend. And maybe this idea of E equals mc squared might actually have applications. Fortunately, one of those people who thought that Einstein's ideas had application was Franklin Delano Roosevelt, and the Manhattan Project came out of that. So it's nice to know that, you know, one outsider got a good hearing for his ideas. But I want you to be clear on the idea that just because one guy can see things in a new way, that doesn't make him some special romantic genius that sees everything in a new way, right? Einstein himself was famously wrong about the other great innovation in physics, which was quantum mechanics. Now, quantum mechanics was more staid. It was being worked out in German universities. But the guys who were pushing it, guys like Heisenberg, right? You know, they really couldn't explain and show evidence for anything they were doing. In fact, they had to come up with all kinds of, you know, sort of interesting ways of arguing that you really couldn't figure out where particular subatomic particles were. Now, Heisenberg had this whole indeterminacy theory, and of course, he could do no better than come up with this as a prop. His cat, right? Explaining, well, you know, if we actually find out whether the cat is there or not in this thought experiment, we'll kill the cat. Nobody wanted to kill the cat. Why did Heisenberg want to kill the cat? Hey, what are we even talking about cats for? Is this science? No, it's a new way of looking at the world. The science came later. The science famously came later in the immediate post-war era when we started smashing atoms together and seeing that subatomic particles acted precisely the way that Heisenberg suspected. Now, you're saying to yourself, all right, I get it. You get it, you know? You're going to have eccentric guys to do pure science. But you know, what do all these eggheads, what application do they have for me? Right? How am I going to make money off of this? Well, let's put it this way. Because of quantum mechanics and the way they work, we came up with a little thing called the integrated circuit. A lot of people will argue that maybe 75% of the tech economy is actually based on that little Heisenberg uncertainty principle. A few other aspects of quantum mechanics. And this wasn't done by guys using the walker and expanding science a little bit at a time in incremental matters. Yes, science does work that way as well. There is a lot of incremental advances, and sometimes those incremental advances are quite important to reach a kind of tipping point. But as Kuhn and others argued, no. A lot of times it's somebody coming along with a new, fresh idea, precisely the sort of person who usually gets labeled a crank, okay? But later on, if they stick with it and people look into their stuff and take it seriously and their ideas seriously, they might find out that, no, this new way of thinking is a great way of doing things. People have actually argued that Kuhn's fundamental insight about science actually applies to all different sorts of human endeavors, so that when people actually crave a way of finding a way of shifting the paradigm. We call this thinking outside the box, okay? But remember, if you're going to encourage people to think outside the box and to innovate, you gotta let go of the box. You gotta let people take a stroll outside that box. And when they actually do so, all the denizens of the box who make their life living in the box and love the box and like to paint the box and set the furniture in the box, you know, they're not going to be too happy that their box is being moved. So you really need to take a look at how these things happen, and quite often they do happen from that fellow who's sitting there in his garage, not having finished college, doesn't look like he's got a good job or anything, and who's playing around for the hobbyist market for toy choo-choo trains. Now, who is that fella? Bill Gates. So go and find your scientific revolution. Go find your guy who's thinking outside the box. Go find your Bill Gates, your Heisenberg, and your Einstein, and stop looking for innovation from guys in white lab coats.